This is API571, Atmospheric Corrosion, read by me, John Fletcher. I hope you enjoyed. Bye for now. Atmospheric corrosion is the process by which metals and other materials are gradually degraded due to exposure to the atmosphere. This can happen when the material comes into contact with moisture, oxygen, and other chemical components present in the air, which can lead to the formation of rust, patina, or other forms of corrosion. Atmospheric corrosion can be accelerated by factors such as high humidity, pollution, and exposure to seawater or other corrosive substances. It can also be affected by the type of metal and material being corroded, as some are more resistant to corrosion than others. Atmospheric corrosion can cause significant damage to infrastructure, buildings, and equipment, leading to costly repairs and maintenance. To mitigate the effect of atmospheric corrosion, various methods can be employed, such as use of protective coatings, corrosion-resistant alloys, and regular maintenance and inspections. Corrosion that occurs from moisture associated with atmospheric conditions, marine environments, and moist, polluted industrial environments with airborne contaminants are the most severe. Dry, rural environments cause very little corrosion. Affected materials: carbon steel, low alloy steel, copper, alloyed, aluminium. Critical factors include the physical location of the plant, the amount of moisture, humidity and rainfall, the presence of salts, sulfur compounds, dirt and other contaminants, chlorides, H2S, fly ash and other airborne contaminants from cooling towers, orientation to the prevailing wind and rain. Corrosion rate increases with temperature up to about 250 F, 120 C. Above 120 C, surfaces are usually too dry for corrosion to occur except under insulation. Designs that trap water or moisture in crevices, marine environments that can be very corrosive, as are industrial environments that contain acids or sulfur compounds. Inland locations exposed to moderate amount of precipitation or humidity are considered moderately corrosive environments. Dry rural environments usually have very low corrosion rates. Bird droppings can also accelerate corrosion and unsightly stains. Affected units or equipment: unpainted, uninsulated carbon steel and low alloy steel piping and equipment operating below 250 F, 120 C when moisture can collect on the surface. Equipment downwind of cooling towers, wet gas scrubbers. Equipment may be susceptible if cycled between ambient and higher or lower operating temperatures. Equipment shutdowns, idle for prolonged periods unless properly mothballed. Tanks and piping are particularly susceptible. Piping that rests on pipe support is very prone to attack due to water entrapment between the pipe and the support. Piers and docks. Bimetallic connections such as copper to aluminium, electrical connections and such like. Appearance or morphology of damage: the attack will be general or localized depending upon the condition of the coating, if any. If there is no coating, corrosion or loss of thickness can be more general and widespread. Localized coating failure will promote localized corrosion. Metal loss may be visually evident, although normally a distinctive iron oxide, red rust scale forms as shown. Prevention and mitigation: paints or coatings are normally applied to otherwise unprotected equipment to prevent atmospheric corrosion. Surface preparation and proper coating application are critical for long-term protection in corrosive environments. Inspection and monitoring. Visual includes direct and line of sight and indirect methods using a camera, mirror, laser scanning and or structured white light imaging with pit gauges. Ultrasonics can include techniques like straight beam or angle beam to directly measure remaining wall thickness, or screening techniques such as EMAT and GWT. Radiography may include traditional film-based, digital or computed radiography, media, and may incorporate techniques such as contact or profile radiography, as well as system imaging. ECT may include a screening technique such as pulsed eddy current. Related mechanisms: corrosion under insulation and concentration cell touchpoint corrosion. And that was API571 atmospheric corrosion, and I'm still John Fletcher. Hope you enjoyed that. You can see my email if you've got any questions, and I'll see you in the next video. Thanks a lot. Bye for now.